Hello, morning everyone. Yeah, now we have a meeting online through this tutorial video. To I designed this video to help you to understand about the assignment problem using GAMS. We have in front of our screen exercise one. I hope you have already received this on Moodle. The problem is about assigning four sources of officials to four destination cities. In this case, we have four different sources. It can be cities, can be countries, uh, can be anything. Uh, and these four sources must deliver to four different destinations. Here we have Raleigh, Atlanta, Durham, and Clemson. Uh, One constraint that you have to meet in assignment problem is that one source can supply only one destination, and vice versa. One destination can receive only one source. So that's the constraint in assignment problem. And before we are doing modeling in GAMS, we need to make or to design our mathematical models of this assignment problem. And then we have the following formulation. We have two indices, I and J. I stands for sources index, and J stands for destination index. And we have three different data. Here we have AI. It is a supply of commodities of source I. BJ mean demand of the commodities of at market source G. And we have CIG. It is cost per unit of shipment from I to G. Means it is from uh, from the sources, for instance, to Raleigh. And the CIG is that, for instance, to A to Raleigh, we have 210 as a CIG. I stand for A and J stand for Raleigh. And we have decision variables. XIG, it is the amount of shipped commodity from I to G. It is not necessarily the amount in physically not the amount, but it is some kind like yes or no, like Boolean variables. If it is one, means there is a shipment from I to G. But if it is zero, means there is no shipment from I to G. As I said before, we have several constraints. For instance, here we have supply limit at plan I, means x sigma xij equal to 1. Why did the sigma has I, small I here? It stands for that among different location of sources, uh, the number of I that's allow shipment only one I. Similarly, for satisfying demand at destination G, we have several destinations, but shipment from I to G allows only shipment only one to one from one I to one G. It cannot be from several I to one destination, or one I to several destination G. It is not allowed. So it is one to one matching I and G. There's a certain I to certain G. Similarly, we have also binary constraint here. As I said before, the variables can have only either 1 or 0. 1 mean no shipment, 0 mean there is a shipment. And therefore, the objective function is to minimize the total cost of shipping from I to G. Here we have CIG. It stands for shipping costs from I to G, certain I to certain G. So that's the uh, sorry, I have to go to here. Yeah, that's the overall objective of this assignment problem. Okay, guys, now we have a GAMS screen here on our computer, and we can start making our first programming in assignment problem. as we know that we have mathematical formulation here. For instance, first we have to define our indices, I for sources and J for destination. Here we can start making, for instance, like sets here, and we can put I stand for sources. Here we have how many? Sorry, A, comma B, comma C, comma D, and we have to close it like this. And we have also several destination. Please keep in mind that different colors, it is good for us to uh, to be aware that the blue color means it is some kind like a sign that the color will not be counted in programming, except if you, for instance, put certain names for like sets, objectives, and parameters, that will be counted. But for instance, like I, it is sources, but sources will not be will be read by this GAMS software. So it is only to make us more clear about what is I, what is G. And J, this destination, we have, okay, make it simple. And for instance, here we have Raleigh, Atlanta, Durham, and Clemson. Okay, Raleigh, and then Atlanta, Durham, Clemson. Yeah, I think so. Yes. And do not forget, each time you end your sets definition, you have to end this sets definition by using semicolon. Sorry, semicolon. Yes, exactly. This is just to tell the GAMS that we have ended our set definition, and we will move to other step, what is called setting or define the parameters. In these parameters, we have only one parameters, I think. Okay, let's try to read again. Yes, we have only one parameters. It is a cost parameters. Yes, to 10, 90. It is cost parameter. It is called parameters. There is a fixed and scalar. And these cost parameters we can define by using. Sorry, we have to put here. Yes, so it look nice. And C, and then I comma J. It is shipping cost. Shipping cost. Yes, from I to J. And we can compose our tables here uh, to for the Raleigh. Yes, okay, Raleigh, and Atlanta, and Durham, and Clemson. No worry about the color change. It will change each time we finish with this table uh, building. And we have A. Maybe it is much better. We have A. We have here B. We have here C. We have here and D. Yeah, these tables actually to compose the cost parameters exactly as the tables that we have already in our PowerPoints. And now, sorry, yeah, we can have this kind of tables, but unfortunately, because we have more than one dimension of parameters, so here Cij is not is not defined as parameters, but it is defined as tables. So at future, if you have a table, sorry, parameters with more than one dimension, for instance, like CIJK, for instance, you have to put table instead of parameters as a definition. Here we can uh, have several number as your tables mentioned in the PowerPoint. Yeah, now I have composed the tables according to our PowerPoint tables. And do not forget to end the table with semicolon. Each time you finish with your sets definition, table definition, just end this sets or end table definition by using semicolon. At the same situation also employ for instance, like if you define your parameters, your variables, your equations, you have to end the definition by using semicolon. It is I think it's quite common in also in other programming languages like in C or in Java. Okay, now what else we can add to this programming language? We have sets, we have tables, we have yeah. Now we need to define our variables. Yes, the variables is we have only one variables here. Variables. There is no any different. We have x I comma j is some kind of like shipping costs from I to j. Is it correct? And oh yeah, now we have also z. It is some kind of like total shipping costs. And don't forget, put semicolon. Sorry, semicolon. Yeah, we have sets, we have table or parameters, or and also we have variables. What is left? We have to define what kind of equations involved in the model. So here we have positive variables. It is also good to mention that these variables cannot be negative by defining as positive variables. We have here also, oh no, sorry, we should not do this way, but we should put positive variable here. So indirectly we tell the GAMS software that X and Z cannot be negative. So the easiest way to state non-negativity instead of putting coding in the equation. And now we have equation here. Okay. Uh, in our problem formulation, we have, okay, how many equation? One, two, three, and yeah, we have four equations. Constraint number one, number two, number three, and objective function. Okay, let's start from constraint number one, sigma xij equal to one. Okay, then we have now equation one. Equation one. What in this involved in equation one, I and j, and we can put double dot, and we should put here summation because we have here we have summation of I. Then we have to put here summation of I, and okay, sorry, we have to put here equation one, sorry, equation 1, equation 2, equation 3, equation 4, and semicolon. Sorry, semicolon. Yes. Yeah, now we have already defined. Please keep in mind that you have to define first your equation. You cannot go directly by stating your equation because GAMS will not recognize your equation. So you have to first define the equation. And then, yeah, we are back to equation number 1. We define this as a AQ1. In making definition about your equation, you should ignore all of this in this involved in the equation. You can just state what is the name of the equation because it is already recognized later in your equation definition. So here we have equation number 1 or EQ1 IJ. It is sum I. So we have xij equal to 1. So we have xi comma j. It is equal, sorry, it is like this. Yes, equal to 1.0 and semicolon. Sorry, semicolon. Sorry. Yeah. Here, xij equal to 1.0. Here, e. This uh, some kind like statement set by GAMS to represent equal to. If, for instance, you want to make greater to than just G, or lower than just L. But here in this case we have equal to. And equation number 2. Equation number 2. What is it about? xgi equal to 1. Okay. Now we can also sorry. Yes, this one. Okay. Now we can put also I comma j here. Dot dot and the same procedures, but here you have to mention it is j, not anymore I, because you have here sigma g. So you sum your sigma, you sum your j, your destination, so that only one destination can receive from a certain source I. So here x again ij, it is equal, sorry, equal to 1.0. Again, now equation number 3. What it tells about? Yeah, the binary constraint. Now we can state also I comma j. So in order to state the binary code, you can state here in equation, or maybe you can change this by using binary variables, comma, semicolon. Here in this it is only variables. uh, you might ask why we have to split into binary variables for xij and z for only variables without any name before variables, for example positive, negative, or binary, or maybe discrete variables. Because z here is a objective function values. We cannot constrain the value of shipping costs. It is some kind of like free variable. It can be takes negative or positive values. Otherwise, there will be some error in processing this optimization. And the binary variables here, just to make our problem formulation be becomes easier and even more simple. Just state binary variables for xij because it will drive the variables to 0 or 1 value. In that case, we have only 3 equation here. We can delete this one. And now the left equation is only the objective function. What is the objective function? We have to minimize the total cost, and therefore we have sum also here I comma j. uh, yeah, because we have to sum all of delivery from I to J, and we have here uh, table Cij times yeah, times xi comma j, and we have to end this equation by using semicolon, because we have here the total shipping cost of variable as z. Then we have to put here z equal to sum of Cij times Xij. Okay, now we have a completed the overall formulation of this assignment problem in our in our class assignment. And then what is the left? We need to include all equation, all used equation into our processing. And therefore we have here to put model. So we have to name our model. Okay, just put in here as a, or maybe assignment, and here EQ1, EQ2, EQ3, and semicolon. And we have to solve the problem to get the result here. Solve assignment using, because here we don't have non-linearities, which means we can solve it as a linear programming. But here we have binary variables, which mean we cannot solve it as a simple linear programming. And in that case, we use another solver here, or another algorithm, namely mixed integer programming, because binary variables also categorized as integer variables but have only 0 or 1 values, and therefore we use MIP, means mixed integer programming. We have to give order to the GAMS. What should we do with this model? Should we maximize or minimize? In this case, we have to minimize, right? So we have to put here minimizing the objective function. So here we have to minimizing z or z. Okay, that's all sorry, our model. Now we can start running the model, and then what happened? And here, oh, sorry, we have some error. What are the errors? Yeah. Now we have $125. Let's see what is the meaning of $125. Here we have, oh yeah, 125 means set is under control already. Yeah, we have to eliminate one indice here, because here we have I already under control. There is nothing wrong with this equation. But the problem is that in equation number 1, we again redefine I here, because it already under control here, means it should be eliminated from this statement. So here we have to delete I, because it already controlled here, Similarly, we have to delete here J, and also here, because ing already defined here, we do not need any more ing here. And okay, let's try to make the to run this model by pressing this button, or just press F9. But I prefer press this button. Yes, now we have several result here. Okay, let's check. Nothing wrong here. Yeah, okay, we can just skip this one. But the most important thing is that you have the result here. So what is the result about? So A delivered to Atlanta, B to Raleigh, C to Durham, and D to Clemson. This is the assignment. To which from which source to which destination it should be, and it is exactly one-to-one matching. So one source to one destination: A to Atlanta, B to Raleigh, C to Durham, D to Clemson. If you, for instance, would like to learn more about what are other results tells about, we have here MIP solution for 450, means the total cost to deliver products from its source to its destination cost 450 something monetary value, maybe US dollar or euro, maybe Danish krona. And next time we will talk about other result that we can extract from this problem. But to this point, I think we have already solved the problem of assignment in our class exercise. And next video, we will discuss about another assignment. What is that? What is about another assignment? Oh yeah, about transshipment. It is more complex, but actually it's not too complex. It is not really too complex, and we can just add one or two more constraints to get the result. All right, so see you on the next video. Thank you.